Good morning to the morning group. Good afternoon to the afternoon group. Good morning, good afternoon. Now say good morning and good afternoon to yourself. Good morning to myself. Good afternoon to myself. Now say good morning and good afternoon to all our friends. Good morning, good afternoon, 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 good morning, 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 afternoon, good morning. You wrecked doing that, wouldn't you? Now, boys and girls, I thought we might do an experiment. Experiment. 4 sounds in experiment. And I'm going to be using a glass of cold water. I'll just tilt it over there so you can see better. This is a glass of cold water. I have another glass here that's empty and I'm going to fill it from the kettle with hot water. So be careful doing this one. Get some help because it's quite hot. And we need hot warm water, what's hot water will do, right, for this experiment. So what do we have? A glass of cold water and a glass of hot water. And I'll just hold this behind. I'll be holding that there so I'll be able to see what's going to happen, okay? Now, so also what I'm going to have to use is some food colouring. So I have some red food colouring here and I'm going to put a bit into the spoon here and I'm going to drop that into the cold water and I'm going to put a bit into the hot water. Okay, and I'm going to hold it up behind so you can see what's going on. Now, as we can see, the water and the food colouring is mixing, but can you see any difference? Any difference between the cold water and the hot water? Can you see any difference between the cold water and the hot water? I think you can see a difference. If you look at the cold water, it's not really mixed well. Sure, it hasn't, no. But look at the hot water. That's mixed perfectly, and this is turned completely red. You can still see the clear water in this glass here. Well, now, isn't that interesting? Now, the question is it magic? No! What is it, boys and girls? It's science. Science. Now, I'll explain the science. I'll just put that down for a second and I'll move that apart a little bit. Hold up. Can you see that there? And I hold on here so you can see that there. Yeah, so now, what is the science? Well, boys and girls, water is made up of tiny, tiny things called molecules. Molecules. Count the sounds. Molecules. If you want to find the sounds in words, sometimes you say them slower. Molecules. 3 sounds. Right? So, molecules are in the water. The water is made up of molecules. And the molecules, they move around. They do move around. That's why we can pour water. Yeah, we can pour water. So molecules, it moves around in water. Now the problem is, or the difference between cold water and hot water is, the molecules in the cold water, they move slowly. Whereas the molecules in the hot water, they move quickly. Slow, quickly. Slow, quickly. So because the molecules in this one are going around much faster, they allow the food colouring to mix. And because this is going around so slowly, it takes nearly ages for it to mix. Now you can still see some of the clear water there, can't you? Look. You can still see some of the clear water. It will turn red like this one, but it takes time. Because why? Well, the molecules in cold water move slower than the molecules in hot water. There you are. It's a nice bit of science. And I can show you that another way by using something else you might have seen. Okay, I'm just going to pause it there for a minute till I clean up my workspace. Oh, look. If you're using food colouring, if the food colouring gets on the counter or on your clothes, it will stain. So wipe it quickly, okay? And if you haven't got food colouring, remember you can mix the paint with water, a little drop of water and paint, and you can try and see if that works, okay? All right, I'm going to pause you for a moment and I'm going to show you what else we can do and showing how the cold molecules are slower than the hot molecules. Okay, 1 second. Now, just had a strange thing happen there. Before I go on with the experiment, I want to show you what happened to my glass. Look, can you see? There's a crack in it, yeah. Do you remember I had the hot water in this glass? Do you remember that? And what happened was I poured it out and then I put some cold water in, and if the glass is too hot and you put cold water in straight away, it cracks. So just be careful with that, right? Because I think I'm going to get into trouble because we only have 2 of these glasses and now we only have 1 Whoops. Anyhow, I'm going to use 2 different glasses for my next experiment, okay? So let's hope that works out. I've taken out our old friends, the STEM glasses. Can you remember these? Yeah, remember the STEM there. And I have cold water in this one, and I'm going to fill this one up with hot water, and hopefully I don't crack this one. Anyway, there we go. Now, the problem with the last time what I did was when I emptied out this hot water, I put cold water in straight away, and that's what cracked. So what you do, you won't crack it putting hot water in, but just leave it and maybe let the water go cold. Now, so I have cold water here and hot water here, alright? And now I have these here, look, tea bags. And watch what happens when I put the tea bags in. I'm going to shake them up and down. Can you see anything happening? Now look at that. Yeah, so if I just hang that there for the side, so you can see this one changed colour almost straight away. Why? Because the molecules are moving through the tea bag and taking out the colour and the flavour of tea and going into the liquid. Whereas this one, now it will happen, but it takes longer and longer and longer and longer and longer. You can see it changing colour, but this is a deep brown colour, or this one's kind of like a yellowy colour, yeah, because the molecules are moving much slower through the tea bag and the tea leaves, whereas this one, they're travelling through much quicker and taking out the flavour. I think that's why people drink tea when they make hot tea, because you need hot water, don't you? Now, I know you can... a lot of people like to drink cold tea, yeah, so they must make the tea hot first, and then maybe let it cool down, or maybe they'll like it like this, I don't know. Anyway, so that's just shows you again how the molecules in cold water move slower than the molecules in hot water. Now, who knew that when you were making tea, you were actually being a scientist? Yes, you were being a scientist, because the hot water reacts with the tea bag and it makes the flavour and the colour spread much quicker. That's because the molecules in hot water move much more quickly than the molecules in cold water. Yeah. Alright, I hope you enjoyed those little experiments, and I hope you don't crack a glass like I did, you big noodle. Anyhow, not to worry. So don't forget to tidy up your space when you're finished and put away everything that you use, because nothing worse than coming into a messy kitchen, alright? Now, so, yeah, I'll talk to you later, you big noodles. Bye!